For our second example, we have the number of students who pass and fail their driving tests at the Department of Motor Vehicles after completing a course at 2 driving schools in town. We have Flint School of Safe Driving and Pass with POPs. Based on the data, use a 10% level of significance to test whether the passing proportions for the 2 driving schools are different. So we want to know, are these equivalent things? Basically, are you just as good going with one school as the other? That's what we're trying to find out. So I'm going to call Flint School Population 1. I'm going to call Pass with POPs Population 2. Okay. Now, in this table, we have our pass and fail. We want to focus on passing rates. So this is going to be X1 and X2. And then we need our totals over here, N1 and N2. So our total from Flint School is 25 people participating in our study, and from Pass with POPs, it looks like we have 29. All right, so now that we have all that stuff labeled, let's write our null hypothesis. So, null and alternative. So again, we wanted to show if they are different. Are the populations different? We are assuming that the proportion of people who pass with Flint and pass with POPs are the same. What we're testing is, are they not the same? Okay. Of course, you can also write this with the subtraction equals 0, or it does not equal 0. Either way is fine on this one. Proportions are always z distributions. And this one we are testing at alpha equals 0.10. To do step 3, we are going to go to the calculator to calculate our z statistic and our p-value. So let me pull up a calculator so you can see this. In the calculator, we are going to go to stat and then over to test. And we want a 2 proportion z-test. So on mine it's number 6, yours would probably be something similar. And then we're going to fill in what we need. So X1 we said was 17, N1 is 25, X2 is 23, and N2 is 29. This is the test that you cannot have decimal values. So if you for some reason end up with a decimal value, you have to round it. We are testing not equal, and we are going to calculate. So when we do that, we get z is 0.945, and our p-value is 0.3443. Let me write those down. So 0.945 and p, I know the calculator disappeared. Okay, we're going to compare our p-value to alpha, and it is clearly larger than alpha, so we are going to fail to reject. And again, I'm not going to write the sentence, but you are going to interpret this with words. You're going to use a sentence to interpret what you mean by this. And you'll say something like, at the 0.10 level of significance, the data does not support that the passing rates differ between the 2 schools. Okay, so those are population hypothesis testing for 2 population proportions.